Hi everyone, my name is Jo Fatina, daughter of Francis Drake, and my matrix number is 33DCE21F1074.
Hello everyone, my name is Tanusha Sukumaran and my number matrix is 33DCE21F1025.
Today we are doing tensile strength test using a virtual lab. The objective is to study the mechanical properties of mid-steel specimen under tension load. The apparatus used is universal testing machine, dial indicators, scale and vernier calipers. Step 1. Measure the initial diameter of tension test sample in two perpendicular directions using vertical caliper. Diameter IX is 11.50 mm. Diameter IY is 11.50 mm. The average initial diameter is 11.5 mm. Step 2. Measure the length of the specimen between the grips using a scale. The length of the specimen between the grips is 192 mm. Step 3 is punch marks are made at the distance of 2.5 diameter. The distance 2.5 diameter is 2.5 times 11.5 is equal to 28.75 mm. Step 4. Insert the specimen into the position and mount extensometer on the specimen. Drag the specimen. Step 5. Readings on the dials A and B of the extensometer are adjusted to 0. The least count of extensometer is 0.01 mm. Step 6 is experiment is conducted. Load extensometer readings are read at regular intervals of the load up to the yield point. Ivory scale readings are noted till the specimen failure. Press the red button to stop and download the data. Next, step 7, the graph. Load versus ivory scale reading. The lowest point is 37 and the highest point is 57. Step 8 is graph. Load versus extensometer reading. The slope of this graph is 1.81. Step 9. Join two pieces of the test sample and measure the diameter at the neck of the specimen. The final diameter is 7.79 mm. Step 10 is measure the final length between three punch marks. The final length between the punch mark is 77.31 mm.
11, that is calculation. To find the yield stress, we have to use lowest value from graph divided by AO. So 37 kilo divided by 103.02. So the answer is 356.39. Next, to find the tensile strength, we have to use highest value from graph divided by AO. So 57 kilo divided by 103.02. The answer is 549.03. Thirdly, to find the modulus, we have to use formula that gauge length divided by AO. So the gauge length is 120 divided by 103.02. After we done divide, we have to times with slope and times with 100. So slope is 1.81. So times with 100 and times with the answer we divide. So we will get 209.21. So next, to find the percentage of elongation, we have to use final length minus punch mark times 2 and divide by punch marks times 2. So final length is 77.21 and minus by 59.24 and divide by 59.24 and finally times with 100%, so we will get 30.50%. So finally, to find the percentage of reduction, we have to use AO minus final area at neck and divide by AO again and times with 100. So the AO is 103.02 minus 47.64 and divide by 103.02 and then times with 100%, we will get 54.11. So this is the result that we get after we done the calculation. Thank you.
The conclusion is the carbon fiber composite material has a much higher tensile strength and modulus elasticity than the other materials. Note they all break in a brittle manner as the curve is linear until it breaks or fractures with no bending of the curve at high loads. Consequently, there is no permanent change in original shape during this test and hence no ductility. And that's all for this test. Thank you.